Okay, and today we're going to learn how to do some operations with matrices. So this is adding more than one matrix together or working with matrices. So let's first learn that a matrix can be denoted by an uppercase letter, say uppercase A or uppercase B, or it can be denoted by inside brackets a lowercase a sub y or a b sub x. Okay, so for example, a matrix is just simply a rectangular array of numbers, such as, let's say I have matrix A, which I could also call matrix A here. And that is equal to A sub 1, 1. Now that sub 1, 1 means that's row 1, entry 1. This is row 1, column 2. Then row 1, column 3. Dot, 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 all the way to row 1, column N. And then our next one would be A sub 2, 1. That's row 2, column 1. Row 2, column 2. Entry for row 2, column 3. All the way up to entry for row 2, column N. And then I can go all the way down to row N, column 1, row N, column 2, row N, column 3, all the way over to row N, column N. Two matrices are equal if they have the same order and their corresponding entries are equal. So these two are 2 by 2 matrices, so they have the same order. So corresponding entries must be the same. So I see that -2 and -2 are the same, 7 and 7 the same, so I need to make x such that it's equal to -4, which means x has to equal -4. And likewise, y would have to be equal to 22. So our corresponding entries and corresponding positions in each matrix have to be the same. You try the next one. Solve for x and y, given that these two matrices are equal. So I can start by taking x plus 2 and equal it to 2x plus 6. Get x is equal to -4. Or the other one, you had a 2x x in, you could have said that 2x is equal to -8. Those are corresponding entries as well. And so it doesn't matter which of the x terms I plug in, it still get x must be -4. So those do correspond. Oh, see, each of these corresponding entries are the same. So the ones are already set up. So I'm making an equal matrix. So for do the y, I could take 2y is equal to 18. And I would get that y must be 9. Or you could have chosen to solve for y using the third row, third entry for each of the matrices and had y plus 2 is equal to 11 and solving for the y and also getting 9. So that's how you solve for x and y when you have two matrices that are equal. Now we're going to look at some matrix operations. We're going to start by adding two matrices together. You can add two matrices as long as they have the same order by adding corresponding entries. So if I wanted to find A plus B, I would simply add my row 1, column 1 entry in the first matrix, which is 1, plus my row 1, column entry in my second matrix, which is -2. And I would repeat this process for all entries. So let me show you with all the steps. So this is a 2 by 3 and a 2 by 3, so I can add them together. And so when I take 1 plus a -2, that's going to be my new first row, first column. And then I'm going to do the same thing for the second row. Adding those together, I end up with my A plus B is equal to -1, -1, -2, -3, 10, and 2. Now this middle step where I put 1 plus a -2, -1 plus 0, you don't have to write that. That is optional. You do not have to show that work. You can do the adding of the matrix, adding of the corresponding entries in your head if you want. You could have went straight to your answer matrix in this case. So that's how you add matrices together. Now, how do you multiply by a constant or a scalar multiplication? So numbers are usually referred to as scalar when we talk about matrices. And in this case, scalars will always be real numbers. Okay, when we multiply matrix A by scalar C, we multiply each entry in A by C. Now, matrix subtraction is actually multiplying by the scalar of -1. So we considered that if we wanted to find A minus B, technically that's A plus -1 times B. But it ends up being the same thing, as it's just taking all the corresponding entries of matrix A minus all corresponding entries of matrix B. All right, so let's do our first scalar multiplication. I want to figure out what 3A is. So that means I need to multiply my matrix A, each corresponding entry by 3. So that will be 3 times 2, which is 6, times 3 times 2, times 3 times 4. Second row, -3 times 3, 3 times 0, 3 times -1, and repeat that for the third row. Again, this matrix work here is not required. You can go straight to your answer. 3 times 2 is 6, 6, 12, -6, -9, sorry, 0, -3, 6, 3, and 6. It's hard to read what that says, but you can skip this step. That's what that says. Okay, now let's do matrix subtraction. So we got A minus matrix B. So technically, again, that's A plus -1 times B. So I'm going to do all the steps. But again, you'll be able to simplify and not have to do all these steps. So this is my matrix A. And I want to subtract or add -1 times my matrix B. So I'm going to distribute -1 times all my matrix B. So that's just changing the sign of every entry in matrix B. And then adding those together. So 2 plus -2 gives us 0, 2, 4, -4, 4, -4, 3, -2, and 0. So that's showing more likely what the work you'll show. All right, so I want you to try this next one. All right, so I'm going to take 2 and multiply every entry in matrix B by 2 to get my 2A matrix. Then I'm going to add, and I'm going to multiply every entry in B by -3 to get my -3B matrix. I do need to see these steps, so that's the order of operations. You got to do multiplication before you do adding and subtracting. Now I can add these two matrices together. Remember, I'm adding these matrices by adding our corresponding entries. So I have 4 plus 3, which gives me a typo there. That should be a 7. Okay, so let's look at some properties of matrix addition and scalar multiplication. So if I have a matrix A and I add a matrix B, that'll be the same as B plus A. So the order does not matter. Okay, if I want to add matrix A, B, and C, and I add A, B, and C first, then add A, that'll be the same as if I add A and B first, then add C. But notice that the order in which I'm writing those A, B, and C did not change. Now, if I want to multiply by a scalar, that'll be the same. If I take the scalars 2 and D, multiply them together, then distribute to matrix A, would be the same as if I distribute matrix scalar D to matrix A, then distribute scalar C to matrix DA. Okay, and then identity matrix is going to come important later on. If that's just one time, if the scalar is 1, so 1 times A is just A. And then distributive property, if the scalar C is multiplied by matrix A plus matrix B, that's the same as scalar C times matrix A plus scalar C times matrix B. Likewise, if I have two scalars being added together, I can distribute the matrix, and C plus D, scalar C plus D times matrix A is the same as scalar C times matrix A plus scalar D times matrix A. All right. So that kind of just talks about, orders of operation, what you can do. So basically in this first example here, I have these 3 matrices. So basically I can add my corresponding entries. So for my first row, first entry, I'm going to add together all my corresponding entries. So that's going to be -5 plus 7 plus a -10. And that'll be my first row, first entry. Second row, second entry, 0 plus 1 plus a -8. I'll do the same thing for the second row. So 3 plus a -2 plus 14. And for the second row, second entry, -6 plus a -1 plus 6. Okay, doing that math, I end up with -8 minus 7 times 15. Second row is 15 and -1. Okay, so here I can add these matrices, subtract these matrices first, then multiply by the scalar, or I can distribute the scalar. So I'm going to choose just to add subtract the two matrices first. And so we have that -4 minus 2 gives us a -6. 0 minus 1 gives us a -1. 1 minus a -2 gives us a +3. Okay, now I can distribute the 4 to each of our, the scalar 4 to each entry in our matrix. And I would get a -24 minus 4, 12, -12, 32, and 12 for our final answer. Now, you could remember I said you can do this 2 ways, so I can start by distributing the 4 to our first matrix, minus distributing the 4 to the second matrix, using our distributive property, and then adding these two together. So -16 minus 8 is -24, 0 minus 4 is negative 4. 4 minus a negative 8 is 12. 0 minus 12 is negative 12. 8 minus a negative 24 is 32. 12 minus 0 is 12. So it doesn't matter which order you do those. Okay, you try the next example. Okay, doing my order of operations, I'm going to start with the parentheses first. I'm going to do scalar multiplication, distribute that negative 1 to that first matrix. And then I'm going to do my parentheses next and add these two matrices inside the parentheses together. Then I'm going to do scalar multiplication and distribute that 1/6 to each entry in the second matrix. I'm just going to copy down the first matrix. Distributing 1/6 to the second matrix, I get 1/3, 2/3, negative 1, 1/2, 1, and 2. And last but not least, I'm going to add these two matrices together by adding corresponding entries together. Negative 4 plus 1/3 is going to give me a negative 11/3. A negative 11 plus 2/3, well, that'll be negative 33/3 plus 2/3, so that's a negative 31/3. 2 plus a negative 1 gives me a 1. 1 plus 1/2 gives me 3/2. Negative 9 plus 1 is negative 8. And negative 3 plus 2 is negative 1. Hopefully that's what you got. Last operation that we're going to learn today is called matrix multiplication. Now, matrix multiplication is a little bit different than the other operations we learned so far today. Now, for the key for matrix operation, matrix multiplication is that if matrix A has a m by n matrix and matrix B is n by p, you can only multiply them if those two entries are the same. So if the columns in the first matrix equals the number of rows in the second matrix, then you can multiply, and only then. And your answer will be the outside number. So the answer matrix will be in the form of m rows by p columns. And with matrix operation, order matters. A times B, matrix A times matrix B is not necessarily equal to matrix B times matrix A. So order is important with matrix multiplication. So yes, I can multiply these two matrices together and to find matrix A times matrix B. So I'm going to copy down my matrix A and then copy down my matrix B. Now, how you multiply matrices is just remember this. Go across the row and down the column. So for the first row, first column, to find my first row, first column entry in my answer matrix, I'm going to go across the row and down the column. So I'm going to take 0 and times it by negative 2. Then I'm going to move over and down. And I'm going to add 4 times 0. Now I'm going to move over and down again. I'm going to add negative 3 times 1. And that sum is my first row, first column entry answer. Okay, remember, go over and down. So forget my first row, second column entry. I'm going to multiply my first row for 0 times 0 plus, now I'm going to move over and down. 4 times negative 4. Over and down. Negative 3 times 2. And that sum is my first row, second column answer. Now to get my second row, first column answer, I'm going to multiply those together, going over and down. So 2 times negative 2 plus moving over and moving down, 1 times 0 plus moving over and moving down, 7 times 1. That whole answer is my second row, first column result. Now to find my second row, second column result, I'm going to move over and down. So I'm going to take 2 times 0 plus 1 times negative 4 plus 7 times 2. And that sum will be my second row, second column answer. Now for my third row, first column answer, I'm going to go over and down, so 3 times negative 2 plus negative 2 times 0 plus 1 times 1. And now I need to get my last entry, which is my third row, second column. I'm going to find the sum of those products. So I'm going to take 3 times 0 plus over and down, negative 2 times negative 4 plus over and down, 1 times 2. For now, I want to see all of this work to make sure you know matrix multiplication. So please show this work as you're working through your matrix multiplication. All right, so now it's just simple addition. So 0 times a negative 2 is 0 plus 0 minus 3. So my first entry here is going to be negative 3. Now, notice that all of those that I'm multiplying by corresponds to that first column in my second matrix. Likewise, 0, -4, and 2 is what I'm multiplying all my entries by in my second column. So it's a way for you to check. Okay, so simple math. 0 plus 0 plus a -3 gives us a -3 for my first row, first entry. Okay, first row, second entry, that's 0 minus 16 minus 6, which is -22. Second row, first entry, that's -4 plus 0 plus 7, which will give us 3. And then second row, second entry, that's 0 minus 4 plus 14, which is 10. And last row, first entry, that's -6 plus 0 plus 1, which is -5. And 0 plus 8 plus 2, which is also 10. And that is how you multiply matrices together. Okay, now I want you to try multiplying B times A. So remember, the first thing you want to do is check your order of your matrix B times A. So matrix B is a 3 by 2 matrix. Matrix A is a 3 by 3 matrix. So 2 and 3 are not the same, so I cannot multiply these together. Done. Okay, some matrix operations that you need to know about matrix multiplication. Given that A, B, and C are matrices and C, little c, is a scalar. The associative property of matrix multiplication means that if I have matrix A times, in parentheses, matrix B times matrix C, that is equivalent to matrix A times matrix B times matrix C. So basically, as long as I don't change the order in which I write these, I can multiply the B and C together first and then take A times the answer, or multiply A to B together and take that answer times C. Okay, if little c is our scalar multiplication, it again doesn't matter which, if I'm multiplying that scalar c by the product of A times B, or first distributing the c to matrix A, then multiplying by matrix B, or distributing it to matrix B, and then multiplying your results together. And the distributive property, I can distribute a matrix through, or I can distribute a scalar through, or a matrix on the back. All right, so basically what's it saying here, it doesn't matter which order in which I write these, as long as I don't change the order in which I write down the matrices, I can operate these in any order. So matrix, I'm going to do matrix A times matrix B, and then times that result by matrix C. All of these matrices are 2 by 2s, and so yes, I can multiply them together. So we'll start by multiplying matrix A and matrix B together. So that gives us, remember, going over and down, so 3 times 1. Plus 1 times -2 would be my first row, first column entry. My first row, second column entry, again multiplying over and down, I'm going to take 3 times 0 plus 1 times 2. Okay, moving down to my second row, first column, over and down, so I'm going to take 0 times 1 plus a -2 times a -2. And for my second row, second column, I'm going to take 0 times 0 plus a -2 times 2. And I'm still going to multiply this by the matrix 1, 2, 0, 4, which I haven't worked with yet. So let's simplify down those sums. So that gives us 3 minus 2, which is 1. And then 2, and then 0 plus 4 is 4, and 0 minus 4 is -4. So now I'm going to take the matrix 1, 2, 4, -4, and times it by the matrix 1, 0, 2, 4. Remember, going over and down. So my first row, first column would be 1 times 1 plus 2 times 2. And then my first row, second column entry will be 1 times 0 plus 2 times 4. And then for my second row, first column entry, 4 times 1 plus a -4 times 2. And finally, for my second column entry, I will take 4 times 0 plus a -4 times 4. All right, so I get 1 plus 4, so my first row, first column entry will be 5. And then 0 plus 8, so that's 8. 4 minus 8, which is -4. And 0 minus 16, which is -16. For my final answer. Okay, now you try one. For this one, I'm going to choose to do the matrix multiplication in parentheses first and then distribute the scalar. but you can distribute the scalar first if you wanted to one of the matrices. All right, so over and down, so 6 times 0 plus 5 times -1 plus -1 times 4 is my first row, first column entry. My first row, second column entry will be 6 times 3 plus 5 times -3 plus -1 times 1. My second row, first column entry will be 1 times 0 plus -2 times -1 plus 0 times 4. And my second row, second column entry will be found by taking 1 times 3 plus -2 times -3 plus 0 times 1. So I still got that -3 scalar. Let's do the math here. That's 0 minus 5 minus 4, which gives us a -9. We have 18 minus 15 minus 1, which gives us a +2. And 0 plus 2 plus 0 gives us 2. And 3 minus 6, 3 plus 6 plus 0 gives us 9. Now I'm going to distribute the scalar to each entry in our matrix by multiplying each matrix by each entry by -3 to get 27, -6, -6, and -27 as my final answer. Okay, let's try one more. Okay, again, I'm going to start by adding those 3 matrices inside the parentheses first, so I'm going to do that first. So all you do, remember to add matrices, is add corresponding entries. So that'll give me 5 plus 7 minus 8. And our second entry will be -6 minus plus a -1 plus 9. And so we have the column matrix 3, -1, 5, 7 times by the row matrix 4, 2. Let's check and see if we can multiply these together. Okay, well, that column matrix is a 4 by 1, and the row matrix is a 1 by 2. And so the inside numbers are the same, so we can multiply that out, and we're going to have an answer that's going to be a 4 by 2 matrix. All right, so first row, first column entry is just 3 times 4. There's no over and down to do. Okay, first row, second column would be 3 times 2. Second row would be 4 times -1 times 4 and -1 times 2. Third row, 5 times 4 and 5 times 2. And the last row, 7 times 4 and 7 times 2. Multiplying those together, I end up with my first row as 12 and 6. Row 2 is -4 and -2. Row 3, 20 and 10. And row 4, 28 and 14. Okay, now I hope you know how to do different matrix operations.